Most of what you've been taught about the origins of civilization rests on a quiet assumption that the deepest, oldest stones built by human hands are still sitting somewhere on dry land, waiting to be cataloged. That assumption may be drifting apart. In recent years, a series of deep-sea drone surveys have returned imagery from depths that, until very recently, no archaeologists seriously bothered to study. And what those drones have filmed: column-like blocks, terraced platforms, eerily aligned passageways, doesn't fit the timeline we keep repeating in textbooks. Some researchers now believe parts of these formations may predate every civilization we've ever named. Others say it's all an illusion. Tonight, we're going down with the cameras. To understand why this story matters, you have to remember something most people forget. The map of human history we use today was drawn almost entirely above water. Cities, temples, roads, tombs, they were studied where they sit on dry continents. But the planet didn't always look the way it does now. At the end of the last ice age, somewhere between roughly 14,000 and 11,000 years ago, the great ice sheets melted in pulses. Sea levels rose by more than 120 meters. That's not a slow tide. That's a planetary reshuffling. Coastlines moved inland by hundreds of kilometers in some regions. Entire plains, river deltas, and shallow shelves, exactly the kinds of places early humans tended to settle, vanished beneath the waves. For most of the 20th century, marine archaeology focused on shipwrecks. The idea of submerged settlements existed, but it was hard to test. The continental shelves are vast, dark, and expensive to survey. Sediment piles up. Storms scatter evidence. Then, slowly, the technology caught up. Multi-beam bathymetry began mapping the seafloor in resolutions detailed enough to spot meter-scale features. Side-scan sonar revealed textures the eye could read. Remotely operated vehicles, like Hercules, working with the support vessel Argus through the Ocean Exploration Trust, started returning crisp 4K imagery from depths that used to be guesswork. The Schmidt Ocean Institute's ROV Sebastian extended the reach further, live streaming dives that anyone with a laptop could watch in real time. And as the resolution improved, the questions changed. We stopped asking whether anything could be down there. We started asking what, exactly, we were looking at. Outlet Yam, off the coast of Israel, is a useful anchor here because it isn't speculation. It's a real, well-documented submerged Neolithic village, dated to roughly 7,000 BCE stone circles, house foundations, even a freshwater well. All preserved under about 10 meters of water in the Mediterranean. Outlet Yam is older than the pyramids by thousands of years. And the fact that it existed at all, intact, beneath the sea, quietly changed how serious researchers thought about the continental shelves. If one Neolithic village survived submersion, what else might be waiting? Pavlopetri, off the southern coast of Greece, deepened the same question from a different direction. Surveyed extensively by University of Nottingham archaeologists, Pavlopetri is a Bronze Age city. Streets, courtyards, building foundations, even tomb structures, submerged in roughly 4 meters of water. It's old, it's organized, and it's been mapped in extraordinary detail using a combination of diver surveys, photogrammetry, and acoustic imaging. Pavlopetri is the kind of site that quietly tells skeptics, yes, real submerged urban remains exist. They just rarely look the way speculation suggests, and the rigor required to verify them is enormous. Every wall is measured. Every artifact is logged. Every claim is constrained by what the stratigraphy will support. This is the world the new deep-sea drone footage entered. Not a vacuum, not a fringe pocket. A legitimate, growing field where the rules of evidence are still being negotiated. And that's where the trouble starts. The footage that triggered the latest wave of conversation didn't come from a single dive or a single team. It came from a slow accumulation of surveys, some commercial, some academic, some buried inside oil and gas exploration archives that nobody had time to fully examine. Bathymetric scans of regions off the coast of southern India, segments of the Gulf of Cambay, stretches of the Mediterranean shelf, sites near the Bahamas banks, deep water near the Ryukyu archipelago in Japan. All of them, at various points, produced anomalies. Right angles where nature doesn't tend to favor right angles. Linear arrangements over hundreds of meters. Step surfaces, possible carved channels. The latest round of attention focused on a deep water survey that descended past the typical recreational diving range, into the cold, low-light layers where sunlight doesn't quite reach. According to researchers involved with the project, the ROV's light swept across what looked, at first glance, like a debris field. Then the camera pulled back. The debris had pattern. Blocks of similar dimension, repeating. Long, low walls that seemed to bend in deliberate angles. A platform-like rise with what some interpreted as the remnant of a ramp. The dive team didn't release a triumphant press conference. They released the footage and the bathymetry and asked for review. Watch the footage closely and you start to notice the small things first. The way silk curls off an edge the drone's thrusters disturb. The almost crystalline geometry of a corner that at certain angles looks worked and at others looks faulted. Fish drift past with that indifferent slowness deep water fish always have. The audio is the steady hum of the ROVs, systems, and the occasional clip chatter of the surface team. It's not theatrical, it's tedious. That's part of what makes it strange. Real archaeology, when you actually watch it happen, mostly looks like nothing. And then, every so often, the camera turns, and there's a shape that doesn't fit. That's the cautious part. The less cautious part is what happened next. Within days, clips were circulating with captions claiming the structures were older than Göbekli Tepe, older than Sumer, older than anything we had a name for. Some commentators connected the imagery to the Younger Dryas impact hypothesis, the proposal popularized, in part by writer Graham Hancock and a small group of researchers, that a cosmic impact event around 12,800 years ago disrupted a more advanced prehistoric society whose evidence supposedly lies submerged. According to this view, the deep-sea structures aren't anomalies. They're the leftovers of a chapter we erased from memory when the waters rose. It's a compelling narrative. It also outruns the data. Let's slow down and actually look at what the drones recorded. Because the imagery is striking, and you can understand why people react the way they do. There are long, parallel lines of stone, some appearing to rise above the surrounding seafloor. There are flat surfaces that almost look polished, though biological incrustation and sediment can mimic that. There are corner-like features where two planes meet at angles close to 90 degrees. In some segments, the ROV pilots described features that, if you saw them on land, you'd casually call walls. On land, you'd photograph them, sketch them, and start asking who built them. But this is the ocean floor. And the ocean floor lies. Not deliberately, it just produces shapes that, to the human pattern recognition system, can look unbearably artificial when they're entirely natural. This is where Dr. Flint Dibble enters the picture. Dibble, an archaeologist at Cardiff University, has spent much of his recent public work pushing back against extraordinary submerged civilization claims. His debate with Graham Hancock on the Joe Rogan podcast became one of the most watched archaeology conversations in recent memory, and his argument, distilled, is uncomfortable for the romantic version of the story. According to Dibble, the kinds of features that excite people in deep-sea footage, the right angles, the apparent blocks, the linear walls, are exactly the kinds of features that natural geological processes produce all the time. Sandstone fractures along bedding planes. Volcanic rock cools into hexagonal columns. Tectonic stress generates joints that intersect at startlingly clean angles. Submarine landslides scatter blocks in ways that, viewed through a narrow ROV light cone, can look organized. Dibble's position isn't that nothing submerged is real. He has openly acknowledged the importance of legitimate underwater archaeology. Places like Atlit Yam, Pavlopetri, the submerged Greek city off the Peloponnese coast, that has produced genuine Bronze Age streets and foundations. His point is sharper. He argues that the burden of proof for an undiscovered, pre-civilizational metropolis is enormous, and that the evidence presented so far doesn't meet it. Pretty footage isn't enough. You need cultural material, tools, pottery, hearths, organic remains. You need stratigraphy. You need dates that come from carbon, not vibes. And here's where the deep-sea footage runs into its hardest problem. At the depths involved, recovering organic material is extraordinarily difficult. Sediment cores can be pulled, but they sample tiny areas. Excavation, in the archaeological sense, is almost impossible. The ROV can see, but it can't really dig. So even if a structure down there is artificial, proving it to the standard a peer-reviewed journal would accept is a multi-decade research program, not a press release. There's also a more subtle issue the working marine archaeologists raise quietly. The deeper the site, the older it has to be, because sea levels were lower in the past. A structure sitting at 100 meters today, if it was built on dry land, has to have been built before that area submerged, which, depending on the region, pushes the construction date well past the last glacial maximum. That sounds like it should support the lost civilization theory. In practice, it complicates it, because the further back you go, the smaller and more dispersed human populations were. The archaeology of the late Pleistocene is mostly stone tools, hearths, and butchered animal bones. Monumental architecture, at that scale, would be a genuine outlier. Not impossible, but it would need to fit into what we already know about how those populations lived, organized themselves, and fed themselves. A megalithic city, in the Bronze Age sense, requires agriculture, surplus, labor coordination. Pre-agricultural societies could build remarkable things. Göbekli Tepe proves that. But the scale and density of a true city is a different problem. Yonaguni, off the southern coast of Japan, is the textbook case study for this exact problem. The Yonaguni Monument is a massive, terraced rock formation that genuinely does look, on first encounter, like a sunken step pyramid. Divers have explored it for decades. Some researchers, including the marine geologist Masaki Kimura, have argued it shows clear signs of human modification. Others, including geologist Robert Schock, have examined the same site and concluded the terraces are natural, the result of sandstone fracturing along predictable planes under specific tidal and tectonic conditions. The debate has never fully closed because the evidence cuts in multiple directions at once. Bimini Road in the Bahamas tells a similar story. A line of large, roughly rectangular limestone blocks running along the seafloor near North Bimini. To one camp, it's a road, a wall, or the remnant of a harbor. To another, including most working geologists who've examined it, it's a phenomenon called beach rock, a naturally occurring formation where calcium carbonate cements beach sand into slabs that crack into block-like shapes as the underlying surface shifts. Both sides have published. Both sides have photographs. The blocks are real. The interpretation is contested. This is the pattern, and the new deep-sea drone footage isn't escaping it. There are, however, parts of this story where the skepticism softens. Dwarka, off the coast of Gujarat in India, is a useful counterexample. Underwater surveys there, conducted in part by the National Institute of Oceanography, have recovered stone anchors, pottery fragments, and structural remains in waters near the modern coastline. The findings don't prove the Mahabharata literally, but they do confirm that something architecturally significant once stood there and was submerged. The dating is debated. Some researchers place the relevant remains in the late Bronze Age. Others push earlier. but the existence of submerged cultural material at Dwarka is no longer really controversial. It's a reminder that submerged doesn't automatically mean fringe. It just means the work is harder. The Gulf of Cambay surveys, conducted in the early 2000s by India's National Institute of Ocean Technology, sit in a more complicated space. Sonar imagery and dredged material from the Gulf produce what some researchers interpreted as evidence of a submerged settlement potentially older than any known Indian civilization. Wood fragments returned radiocarbon dates suggesting ages well beyond the Indus Valley timeline. The findings electrified parts of the alternative history community. They also drew sustained methodological criticism. Skeptics, including a number of Indian archaeologists, argued that the dredged materials couldn't be cleanly tied to the structures shown in sonar, and that the dates might reflect ancient driftwood rather than constructed timber. The case is, at best, unresolved. That word, unresolved, keeps coming back, and it's the most honest word in this entire field. So what do we actually have from the latest deep-sea drone work? We have higher resolution imagery than ever before. We have a growing catalog of seafloor features that look unusual. We have a few sites where careful, conventional archaeology, Atlit Yam, Pavlopetri, parts of the Dwarka complex, has produced genuinely surprising results. And we have a much louder, faster ecosystem of online interpretation. That races ahead of the science, sometimes carrying real findings with it, sometimes carrying speculation dressed in a lab coat. A reasonable middle path is starting to take shape. Several mainstream marine archaeologists, including teams associated with the Honor Frost Foundation and the European Marine Board, have called for systematic, well-funded surveys of submerged continental shelves, not because they expect lost cities, but because they accept the obvious geographical point. Coastlines were where humans lived. Those coastlines moved. If we ignore the shelves, we are ignoring some unknown but probably non-trivial portion of the prehistoric human record. That's not a conspiracy. It's just a methodological gap. What might the deep-sea drones eventually find? Probably not the gleaming metropolis of speculation videos. More likely, something quieter and almost more interesting. Small settlements, fishing camps, stone circles, foundations of villages from the late Pleistocene and early Holocene, the period when sea levels were still rising and people were learning to farm. These wouldn't rewrite all of human history, but they would push specific regional timelines back, and they would force textbook authors to redraw maps that have stood unchallenged for decades. And there is a slim but real chance, researchers are careful about how they phrase this, that somewhere on the shelves, particularly in regions like the Sunderland Shelf in Southeast Asia, or the Doggerland area in the North Sea that we already know was inhabited, there may be evidence of social complexity earlier than the conventional models suggest. Doggerland, the submerged landmass between Britain and continental Europe, is the cleanest example. We know people lived there. We have their tools, their fishhooks, even fragments of human remains pulled up by trawlers. We don't have a city, but we have a lost world, undeniably, and the deep-sea drones are slowly mapping its outlines. Where does this leave the megalithic city footage that started this conversation? Honestly, in the gray zone. The imagery is real. The features are unusual. The interpretation is wide open and the strongest. Claims are almost certainly running too far ahead of what the data can support. Could there be artificial structures down there? Possible. Could the formations be entirely natural, produced by the same geological processes that built Yonaguni and Bimini Road? Equally possible. We don't yet know. And anyone telling you they know, in either direction, is selling certainty the evidence doesn't yet carry. That uncertainty is uncomfortable. It's also where real science lives. The history of archaeology is full of moments when the consensus shifted because somebody finally went and looked, carefully, at a place nobody had bothered to study. Göbekli Tepe was a low hill in southeastern Turkey that locals had farmed around for generations before Klaus Schmidt's team began excavating in the 1990s and revealed monumental architecture from roughly 11,000 years ago, older than agriculture, older than pottery, older than almost everything the textbook said was possible. The deep ocean might hold its own Göbekli Tepe moment. It might also hold nothing more than beautifully fractured stone. Both outcomes are scientifically valuable because either one teaches us something about how the planet and our species actually behaved. For now, the drones keep going down. New surveys are scheduled. Old footage is being re-examined with better software. Researchers are quietly applying for grants to investigate specific anomalies with sediment cores, scrape samples, and high-resolution sub-bottom profiling. The peer-reviewed papers, when they come, will arrive slowly. They always do. And the public-facing narrative, the viral clips, the heated debates, the confident pronouncements on both sides will keep moving faster than the science can verify any of it. If there is a lesson in this, it might be this. The ocean covers more than 70% of the Earth's surface. Until very recently, we had explored a tiny fraction of it in any meaningful detail. The idea that we already know the full story of human prehistory, when most of the places early humans actually lived are now underwater, is the kind of confidence the evidence doesn't really support. Equally, the idea that a lost super-civilization is waiting in HD, just one more dive away, isn't supported either. The truth, if we're patient, is probably going to be messier, slower, and more interesting than either version. So the cameras stay rolling. The bathymetry keeps refining. Names like Atlit Yam, Dwarka, Pavlopetri, Yanaguni, and the deeper, stranger sites still being mapped will keep showing up in the literature, sometimes downgraded, sometimes upgraded, occasionally reinterpreted entirely. Dr. Flint Dibble and his colleagues will keep insisting on stratigraphy and dates. Others, with different priors, will keep pointing at the imagery and asking the question that started all of this. What? If we've been looking in the wrong place all along, the story isn't over. It probably won't be over in our lifetimes. Every dive returns more data. Every new sonar pass redraws a small piece of the seafloor in higher resolution than the pass before. The deep-sea drones are still descending tonight, somewhere, their lights cutting through cold water at depths we couldn't reach a generation ago. And whatever's down there, natural, artificial, or some mixture of both we don't yet have words for, is still waiting, patient as stone, for the next camera to find it.